to be talking about converting temperatures and chlorine dosage. So let's learn how to convert temperatures from degrees centigrade, Celsius, to degrees Fahrenheit, and from degrees Fahrenheit to degrees centigrade, also known as Celsius. So to convert from degrees Celsius to degrees Fahrenheit, we multiply the degrees Celsius by 9, divide that result by 5, and then add 32. Or we multiply the degrees Celsius by 1.8 and then add 32. So degrees Fahrenheit is equal to degrees Celsius times 9/5 plus 32, or degrees Celsius times 1.8 plus 32. The reason that it doesn't matter which one you use is because 9/5 is equal to 1.8. To convert from degrees Fahrenheit to degrees Celsius, we subtract 32 from the degrees Fahrenheit, multiply that result by 5, and then divide that result by 9. Or we subtract 32 from degrees Fahrenheit and then divide that result by 1.8. So degrees Celsius is equal to the degrees Fahrenheit minus 32 times 5/9, or degrees Fahrenheit minus 32 divided by 1.8. Now that we know this, let's do one question. So 15 degrees centigrade Celsius is equal to what on the Fahrenheit scale? So we use the formula degrees Fahrenheit equals, we're going to use degrees Celsius times 1.8 plus 32. Okay, so degrees Fahrenheit is equal to degrees Celsius times 1.8 plus 32. Now, what is the degrees Celsius? We know that, that's 15. So 15 times 1.8 plus 32, so now we use a calculator. And we're going to do 15 times 1.8 and then add 32. And we get 59 degrees, so 59 degrees Fahrenheit, answer A. Okay, and next we're going to convert Fahrenheit to Celsius. So 86 degrees Fahrenheit is equal to what on the centigrade Celsius scale? So we're going to use the formula degrees Celsius equals degrees Fahrenheit minus 32. Divided by 1.8, of course. So Fahrenheit, oh, not spelling that right, Fahrenheit minus 32, and that will be divided by 1.8. Okay, so now we plug in what we know. We know that the Fahrenheit is 86, so we plug that in. So now we have 86 minus 32, and then we're going to divide by 1.8. And we get 30, so that's 30 degrees Celsius. So our answer is A, 30 degrees Celsius or centigrade. Okay. So chlorine dosage. The formula is CD for dosage of chlorine is equal to C over W times 1,000, where CD is the chlorine dosage in milligrams per liter, C is the weight of the chlorine that is added in kilograms, and W is the volume of the water in liters. So let's do a question. So calculate the rate of chlorine dosage in milligrams per liter if 3 kilograms of chlorine is added to a reservoir containing 1,000 cubic meters of water. Now we might need to remember, in fact we will need to remember, that each cubic meter holds 1,000 liters of water. So what we're going to do is we're going to set up the CD. I can't really write that as a subscript, so I'm just going to write that as a lowercase. So CD equals C, which is the weight of the chlorine in kilograms, so 3, divided by W, which is the volume of the water in liters. So there's 1,000 cubic meters, and every cubic meter has 1,000 liters, so it's going to be 1 million. And then we multiply that by 1,000. So this is like 3 times 1,000 divided by a million. So 3,000 divided by 1 million is 0.003. But now we need to think about what is that unit. So CD equals 0.003. But what we did was we multiplied the kilograms by 1,000, so we got grams per liter. So this is grams per liter, but we need milligrams per liter. So we actually need to multiply it again by 1,000, so we get 3 milligrams per liter. So the answer is going to be B, 3 milligrams per liter. So for dosage rate, the formula is D equals Q times C, where D is the dosage rate of chlorine, C is the desired chlorine concentration, and Q is the flow rate. The formula can be rearranged to C equals D divided by Q, where C is the desired chlorine concentration, D is the dosage rate of chlorine, and Q is again the flow rate. So let's do a few examples. So if the chlorine demand of water is 1.6 milligrams per liter, and you want a residual of 1.0 milligrams per liter, how much chlorine would need to be fed to 1 million liters? Okay, so let's see here. So we need to find the amount of chlorine. So what we need is the D. So D equals Q times C. But next, let's figure out if the chlorine demand is 1.6 milligrams per liter and you want a residual of 1.0, you got to add that together to get the chlorine concentration that you need. You need 2.6 milligrams per liter. So we are going to figure this out by inserting 2.6 in for the chlorine concentration, the desired chlorine concentration, and then Q is the flow rate. So Q is the amount of water, so 1 million liters. And then the dosage, what will that be? So we use our calculator and we multiply that out. We remember that 2.6 is in milligrams. So 1 million times 2.6 gives us 2,600,000 milligrams. So if we want to get to grams, we divide that by 1,000. And if we want to get to kilograms, we divide that by 1,000 again. So 2.6 kilograms. Okay, so next, calculate the required feed, so the dosage rate of chlorine, if the desired chlorine concentration is 6 milligrams per liter, and the flow rate is 100 meters cubed per day. So the formula is D equals Q times C that we're going to use. So we want to know the dosage rate. We know that the desired chlorine concentration is 6 milligrams per liter, and we know the flow rate is 100 meters cubed. So that'd be we have to realize that that each meter cubed is 1,000 liters, so 100,000 liters, so that we have the same unit as with C, 6 milligrams per liter. So now we need to figure out how many kilograms we need per day. So it's 100 meters cubed per day, 100,000 liters per day. So we are going to multiply this out. So we get 100,000 times 6. So that's going to be 600,000 milligrams. So we need to divide that by 1,000 to get grams, and divide that by 1,000 again to get kilograms. So we get 0.6 kilograms per day. Next, it says a well pump delivers 80 liters per minute. The chlorine feeder is set at 8 grams per hour. Calculate the chlorine dosage in milligrams per liter. So the formula we're using is C equals D divided by Q. And so we want to know the chlorine dosage. we have that the dosage is 8 grams per hour. So 8 grams per hour. And we know that it's 80 liters per minute. Now we don't want to use 80 because we have 8 grams per hour. So we need to know how many liters per hour. So we're going to multiply 80 by 60 and get 4,800. And then we are going to do 8 divided by 4,800 liters per hour. So now we need to figure out, this is grams. So that many grams per that many liters. So now we got to figure out how many grams per 1 liter. So 8 divided by 4,800 equals, so it's 0.001666. Now, just from those numbers, you probably could guess which multiple choice answer is correct. It is still in grams though, so we need to multiply that by 1,000 to get milligrams. So we get 1.7 milligrams per liter. So right there. So here are some words of general advice. So whenever you are writing a multiple choice test, eliminate wrong answers to make answering the questions easier. Do not spend too much time on any one question. If after you eliminate wrong answers, you still cannot hazard a guess, leave the question and come back to it later. While we do not use the units while doing the calculations in math, it is still very important to make sure that your result is in the same unit as that of the answer. It is often easier to convert the units at the beginning of the question. Remember to use the formula sheet and to use your calculator. So that's all I have for you today. Best of luck with the quiz and any certification tests that you're taking, and be sure to get the quiz submitted.